Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good morning, grade 9 learners. Welcome to today's natural sciences lesson. My name is Mr. Sianda Madala, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, for our term 4, we are still exploring the planet Earth and beyond strength, right? So today I want us to focus on the atmosphere as one of the spheres of the Earth's system, right? I want us to focus on the atmosphere and its layers. So our subtopic for today is the atmosphere, troposphere, stratosphere, mesosphere, and thermosphere, right? That's what we'll be exploring more in depth for today. So now let's look at what we need to achieve by the end of this lesson, which is our lesson objectives, right? So by the end of this lesson, you should be able to explain that the atmosphere is the mixture of gases held around the Earth by gravity. That's what you need to do first before you go on with the lesson, right? Make sure that you are able to explain to the next person that the atmosphere is the mixture of gases held around the Earth by the force of gravity. Secondly, you should be in a position where you can explain that the atmosphere has 4 layers on its own. And the layers are the troposphere, the stratosphere, the mesosphere, and the thermosphere. Also, you should be able to discuss each layer of the atmosphere. So you should be in a position where you can be able to tell the next person about the layers of the atmosphere in depth. And also, you need to be able to explain that each layer has a different temperature gradient. That's all that you need to focus on for today's lesson, right? And all this information is found under the CAPS document on page 81 to page 1 to page 82. Now, let's look at what we have done before, right? Our pre-knowledge. In grade 4, we have discussed the Earth and the Sun, right? So we have discussed the Earth and the Sun. We said that planet Earth is the only planet that accommodates life, right? And also we have the Sun, which has a direct relationship with the planet, right? And also, in the same grade, which is grade 9, we have discussed the Earth as a system. So we said that planet Earth has different parts that work together to bring about what? Life, to support life, and also to make a whole working system as a planet, right? So now, the Earth as a system, it is composed of 4 spheres, as we have said, right? Which is the lithosphere, the hydrosphere, the atmosphere, and the biosphere. So as you can see here from our picture, this is planet Earth, and planet Earth is made up of all these, all 4 different what spheres, which include the lithosphere being the solids of the Earth, right? The solid rocks and soil of the Earth. Then the atmosphere being the gases in the air. Then the hydrosphere, which is all the water in all its forms in terms of liquid, solid, and also gaseous state. And also we talked about the biosphere, which talks about the living organisms interacting with each other, and they're also interacting with what? With the non-living organisms to bring about what? A whole functional system, which is planet Earth. So now, let's look at this baseline activity, right? I need us to test ourselves using this baseline activity to see how far we know, right? For number 1, define atmosphere, right? You should be able to define atmosphere because we have done it when we talked about what? The spheres of the Earth. Then number 2, name any of the gases found in the atmosphere, right? So now I'm going to give you a quick 3 minutes to write down this activity. Welcome back, grade 9 learners. Now, going forward, should you have any questions or comments regarding this lesson, you can WhatsApp us on our WhatsApp number on the screen. If it's not on the screen, it is 079 578 2908, right? We'll be more welcoming and more glad to answer to your questions. So now, let's look at the solutions, right? Number one is saying define atmosphere. How do we define the atmosphere? We define the atmosphere as the mixture of gases which are held around the earth by the force of gravity. Then you give yourself a tick. Then number two, name any of the gases found in the atmosphere, right? The gases that are found in the atmosphere include oxygen, nitrogen, carbon dioxide, water vapor, and argon, right? So should you have named any of those, give yourself a tick as well. So let's just take a quick minute to write down the corrections. Welcome back again. Now let's sail through together with our lesson, right? Let's look at the first terms that are important for us to be able to understand this topic, right? First of all, we have atmosphere. How do we define the atmosphere? Atmosphere is the mixture of gases held around the earth by gravity, right? And also we have air. And air is defined as the mixture of gases that make up the atmosphere. Then we have what? Density. What does it mean when we say something is dense, right? Density is the amount of mass in a given volume of a material. Also, we have troposphere. And troposphere is the lowest layer of the atmosphere, which is the closest to the surface of the earth. Then we have stratosphere, which is the second layer of the atmosphere from the Earth's surface. Then we have mesosphere, right, which is the third layer of the atmosphere from the Earth's surface. Then we also have thermosphere, which is the fourth layer of the atmosphere from the Earth's surface. Then we have altitude, right? Altitude is the height above sea level. Then we have temperature gradient. By temperature gradient, we mean how much temperature changes with altitude, or how much temperature changes as you go higher. Are we together? So now, let's look at our main meal now for today. The atmosphere, right? And we're going to talk mainly about the gases of the atmosphere. First of all, we said that the atmosphere is the layer of gases around the earth which is held by gravity. So before we continue, I would like to take you back to our term 3, right? When we were doing forces, we've mentioned what? The force of gravity. And we said that the force of gravity is the force that pulls everything towards the center of the earth. Now look at this. We're talking of the atmosphere today, right? The atmosphere is the layer of gases or the mixture of gases which is around the earth. And it is held together by what? By gravity. So also it is pulled down by the force of gravity to keep it in position, right? So that it stays in position around the earth. So now, this mixture of gases that we're talking about around us is known as air, right? The air that you and I breathe in and out, right? And air is composed of various gases, which include carbon dioxide, oxygen, water vapor, and so on, right? So the mixture of gases that we're talking about here is known as air, right? Air, which is part of the atmosphere. So the atmosphere, we're saying now, it is one of the four parts of the Earth's system and is essential for many processes on Earth. What do we mean by that? Now, if you think of the atmosphere, right, it is the layer of gases. And which gases do we find in the atmosphere? I've mentioned oxygen, I've mentioned carbon dioxide, I've mentioned also nitrogen, right? So now, the atmosphere forms what a part of the it forms what part of the Earth's system, and also it is essential for many processes on Earth. Now, if you think of those individual gases that I've mentioned, photosynthesis, for example, right? Photosynthesis, it needs what? Carbon dioxide, right? So that plants can be able to photosynthesize. They need what? Carbon dioxide. Where does the carbon dioxide come from? From the atmosphere, right? Living organisms, for cellular respiration, they need oxygen, which comes from the atmosphere, right? So now, it plays a very essential role for many processes of the earth. Are we together? So also, without the atmosphere, there would be no life on Earth, right? So because all living organisms depend on oxygen to survive, to carry out cellular respiration as well, and other living organisms, such as plants, they depend on the carbon dioxide, which comes from the atmosphere as well. So we can safely say that without the atmosphere, there would be no life on Earth. Moving on, right? So now, the air, right, that we're talking about, it mainly consists of two gases, right? It mainly consists of mainly two gases, right? And those gases are your nitrogen, which contributes about 78% of the air that we find in the atmosphere, and also oxygen, which contributes about 21% of the air that we find in the atmosphere. So these gases, both of them, this 78% of nitrogen and 21% of oxygen, they make up 99% in total. So the two gases alone make up 99% of the air and are always present in the same proportions. So when you breathe in that air, right, you are breathing in air that consists of 78% nitrogen and also 21% oxygen. They are always in the same proportion in the atmosphere that is around us. So what about the other 1% out of the 99% of, or 100%? The other 1% is made up of many different gases as well, which include carbon dioxide as well, which include carbon dioxide, water vapor, and argon, right? So now to show you in the form of a pie chart. Now, when you look at this pie chart, it has different colors, right? Now, the biggest piece of the pie, which is the blue part, is written 78%. That 78% is the one that represents the nitrogen in our atmosphere or in the air that we breathe, right? And also oxygen carrying about 20.9%, which is equivalent to 21%, right? Then the other gases such as carbon dioxide, water vapor, argon, and so on, they fall under that 1%, and in this pie chart, they fall in the other different colors. Now, the density of the atmosphere. How dense is the atmosphere, right? Let's look at that deeply. So now, let me remind you, density of a material refers to the amount of mass in a given volume of that material. So we're going to look at more into that, right? So now, in the atmosphere, most of the mass of the atmosphere lies less than 10 kilometers above the Earth's atmosphere. So meaning what? It lies within the first layer that we find from the Earth's surface. So it is mostly dense there, right? It is most dense there because this is where we find most of the mass of the atmosphere. This is where we will find more gas particles, right? Or air particles. So the density of gas particles decreases with distance from Earth. So meaning the higher you go, the less denser the atmosphere becomes, right? So it decreases with distance from Earth, and the air gets thinner and thinner as you go up. So now, eventually what is going to happen? The density is going to be so low that the atmosphere just blends into space. Let's look at this diagram to explain this further, right? We said that in the atmosphere, most of the mass, right? Most of the mass is found where? It is found between what? Or less than 10 kilometers above the Earth's surface. So it is within the first layer of the atmosphere that we find with altitude, right? With height above the Earth's surface. So what happens here? When you look at this diagram, right? This diagram has altitude in kilometers, it has relative density, and it has pressure, right? So now looking at those units, we're going to compare the density as we go up with the graph, right? So looking at this, from 0, that's where you find what? The Earth's surface, right? Now going up from 0, that right there at 10 kilometers. Now I want you to go with the graph with me, right? Right there at 10 kilometers. Let's look at this, right? This is where we find the most dense part of the atmosphere. Now, why am I saying so? Look at this, right? There's more gas particles around this area, right? As compared to the areas upwards. There's more gas particles around this area. This is where it is mostly dense, right? This is where it is the most amount of mass. But look at this carefully. The sooner you go up from these 10 kilometers, approaching 20, then the gas particles start becoming what? Loose. They start becoming far away from each other. And as you go further higher, what happens? The gas particles move further apart as well. And when you reach about 120 kilometers of altitude, what happens? You only find a few gas particles. So meaning what? As you go higher, the air becomes thinner and thinner, right? It becomes less dense. So now, let's talk about the layers in the atmosphere now, right? Because we have seen now that in the first layer, it is mostly dense. When you go to the second layer, the density decreases, and to the outermost layer, you find that it is more or less dense now, right? So now, let's talk about these layers of the atmosphere. First of all, the atmosphere is made up of 4 layers, right? It is made up of mainly 4 layers. Now, those layers are named what? Are named the troposphere, the stratosphere, the mesosphere, and the thermosphere. Those are the 4 spheres of what? Of the atmosphere, or the layers of the atmosphere. Troposphere, stratosphere, mesosphere, and thermosphere. Now let's look at this diagram again. Now this is the Earth, right? As you can see here, this is planet Earth. And now, above planet Earth or around planet Earth, that's where you find the layer of gases called the atmosphere, right? And I just said to you now, the atmosphere on its own, it consists of 4 layers, which we're going to talk more about now. So when you look at planet Earth, as you go up from 0 to 10 kilometers, right, around the Earth, you start finding the first layer, which is the most dense layer of the atmosphere, right? From 0 to 10 kilometers, you find the first layer being the troposphere. When you move upwards now, right, from the troposphere, from that 10 kilometers, right, from 10 kilometers to 30 kilometers, you find what? The second layer of the atmosphere, named the stratosphere. Then, from that 30 kilometers to 50 kilometers now, you find another layer, right? Which is the mesosphere. Then from that 50 kilometers to about 400 kilometers, it is that thick, right? What do you find now? You find the last layer, which is the thermosphere. Then now, from that thermosphere going upwards, that's where you find the outermost, which is no longer within what? The planet Earth, right? It is within space, which is the exosphere. But today I want us to focus only on the first 4, right? Which is the thermosphere, the mesosphere, the stratosphere, and the troposphere. Now, the temperature in the atmosphere, right? The temperature in the atmosphere as a whole. So we're going to talk of temperature in the atmosphere, referring to the temperature gradient in each layer, right? So now, the temperature of the atmosphere is not constant, meaning from layer to layer, from the troposphere to the stratosphere, mesosphere, and thermosphere, the temperatures are different as you move along those layers. It is not constant, right? It is not constant because in some layers it increases with height, whereas in some layers it decreases with the same height, right? So in some layers, as it says here, it increases with height above sea level, or it increases with altitude, and in other layers, it decreases, right? It is not constant. So now, just to remind you, right, height above sea level is called altitude. So now let's explain this in the form of a picture, right? So now, how much the temperature changes with altitude is called the temperature gradient, as we have said, right? So looking at this diagram here, right, it has the layers of the atmosphere. And I just said that the temperatures vary, they are not constant from layer to layer. Because what? Some layers it increases with height, and in some layers the temperature decreases with height. So let's look at this. Let's say this is our Earth's surface. So as you go up from 0 to 10 kilometers, you find which layer? You find the troposphere, right? So when you look at the troposphere here, or looking at this graph, it has altitude and it has temperature, right? And now the temperature is right here at what? At 0 degrees, right? So as you move up with the layer of the atmosphere, right? What happens? The temperature decreases. Where? In the troposphere specifically, right? In that layer, the troposphere, the temperature starts to drop. Look at this, it has moved from 0 degrees to a minus 60 degrees. So now, when it reaches the second layer, also the temperature changes, right? It moves from that 60 degrees and therefore it goes back to 0 degrees again. So what can we say with the following layer? It means that the temperature there, it increases with altitude. So for the first one, the troposphere, we can easily say that the higher you go, the colder it gets. But when you reach the second layer, which is the stratosphere, right? The higher you go, the warmer it gets. Do you find the difference now, right? So now, from the third layer now, when you go up, right, what happens? It moves from that 0 again to about what? A minus 80 to minus 90 degrees Celsius. So now, the third layer, it's the higher you go, the colder it gets. Then the last layer, it starts from that minus 90 degrees and starts to rebalance again, and the temperature rises, right? As the temperature rises, it goes there up until Boma minus 20 degrees Celsius. So for the last one, we can say what? We can say that the higher you go, the hotter it gets, or the higher you go, the more the temperature increases. So you can see that some layers, the temperature increases with what? With altitude, and in some layers, it decreases with altitude. So now, here's activity one, right? I want us to test what we have learned so far. So it has 1, 2, 3, 4, 5 questions. So I'm going to give you 5 minutes, but firstly, let's go through the questions together, right? Number one, it says, what holds the atmosphere around Earth? Then number two, which two gases make up most of the gases of the atmosphere? Number three, how does the density of the atmosphere change with altitude? Number four, in which layer does the Earth's weather occur? Then in number five, why is the ozone layer important, right? So now let's go through these questions quickly and come back after 5 minutes. Welcome back again, grade 9 learners. I hope you were able to answer these questions, right? You can send us your answers to our WhatsApp number 079 578 2908. Now, let's look at the solutions for our activity 1. Number 1 was saying what holds the atmosphere around Earth? And we said that the atmosphere is held by the force of gravity. Number 2, which two gases make up most of the gases of the atmosphere? And that is your 78% and 21%, right? Your nitrogen and oxygen. Then number 3, how does the density of the atmosphere change with altitude, right? So it decreases. The higher you go, the density decreases. Number 4, in which layer does the Earth's weather occur? It occurs in the first layer, which is the troposphere. Then number 5, why is the ozone layer so important, right? It is important because it protects on Earth from harmful ultraviolet radiation from the sun. So now I want you to take a quick minute to copy down the corrections. Right, welcome back again. Let's move on with our lesson, right? So now we're going to discuss each layer of the atmosphere, right? Starting off with the first one that we find from 0 to 10 kilometers, which is the troposphere, right? So the troposphere is the lowest of the atmosphere's 4 layers, right? It is within, not almost at our reach, but it is where we find our precipitation, where we find our weather, and so on, right? So it is the lowest of the atmosphere's 4 layers. Because now it extends from the sea level to about 10 kilometers above the Earth's surface, right? As I've mentioned. Now looking at this structure as well, right? This is the Earth's surface, right? It extends from 0, right? From 0, then going above with height above sea level, it is ending there by 10 kilometers. So it extends from what? From 0 to 10 kilometers above the Earth's surface. Now, when you look at this again, this is where you find our clouds, right? And this is where you find our weather. Let's talk more about it in terms of its mass and density, right? So now, what's the mass and density of the troposphere? We say that the troposphere contains more than 70% of the mass of the atmosphere because this is where we find the most density, right? The most dense part of the atmosphere. So it contains more than 70% of the mass of the atmosphere, and this means that 70% of all the gases or gas particles are located within 10 kilometers of the Earth's surface. Hence, we are able to utilize the gases around and be able to breathe in and out and carry about other life processes, right? So density, it decreases with height within the troposphere too. From that 0 going upwards, right? The higher you go, it starts to decrease as the gas particles move far away from each other in the troposphere, right? Just to remind you, remember the troposphere extends from 0 to about 10 kilometers above the Earth's surface, right? So when you look at here, from 0, 2, 3, 4, 5, it is mostly dense there, right? But when you start to pass 5, approaching 10 kilometers, now the gas particles, they start moving away from each other and becoming less dense than the initial point. Now, what's the temperature gradient in the troposphere, right? So temperature in the troposphere decreases as the distance above the Earth's surface increases, right? The higher you go, the colder it gets in that layer of the atmosphere, right? So this explains why there is often snow on top of a mountain, but less or no snow at its base. Now, let's think of two examples, right, that we normally know of. Mountain Kilimanjaro or Mount Kilimanjaro, right? Mount Kilimanjaro is found in Tanzania. So when you look at this picture here, right, where can we find the snow or ice? It is right on top, right? This is because of the changing temperatures in that layer of atmosphere, right? So the higher you go, the colder it gets. So that's why you find ice or snow on top of this mountain compared to its base. When you look at its base, there is less or no snow at all, right? This is because of what? The temperature is not the same as you go high in that uh, sphere of the atmosphere. Another example is Mount Fuji, right? Mount Fuji, also the same goes for it, right? It is highly containing snow at the top compared to its base, because the higher you go, the colder it gets in that troposphere, right? So now, what occurs in the troposphere, right? This is the only layer in which clouds form, right? So when you see a formation of clouds, it is in the troposphere because it is the only layer where clouds form and different kinds of precipitation like rain, hail, and snow fall to earth. Now, this is where we find different types of clouds as well. Clouds as like the cumulonimbus clouds, the cumulus, the nimbostratus, the stratocumulus, the stratus fog, cirrus, and cirrostratus, and so on, right? This is where we find different types of clouds in the atmosphere. And these processes are part of the water cycle, right? We're talking of now the rain, the hail, snow that falls where? In or onto the earth, right? So now they are part of the water cycle. This is because, right? It's because almost all of the water vapor in the atmosphere is found in the troposphere, right? Most of the water vapor in the atmosphere is found in the atmosphere. And the water vapor is carried upwards by rising air, and air that rises through the troposphere stops rising when it reaches the stratosphere. So most of the water vapor is found within the first layer, which is the troposphere. So all animals and plants, they live in the troposphere, right? Because this is where we find an abundance of what? Of gases that we rely on. So plants and animals live only in the troposphere, though some birds do fly higher than its upper limit occasionally. Also, the troposphere is the only layer in contact with the hydrosphere, right? And also the lithosphere. So it can be part of the biosphere because also it accommodates life, right? It is, and also it is interacting with all the other spheres. Hence, we say it is part of the biosphere. Remember, biosphere is the interaction between living organisms and their interactions with the non-living organisms, right? So now the troposphere also, as it forms part of the atmosphere, it also forms part of the biosphere. So now, even within the troposphere, life is mainly found in the lowest 2 kilometers closest to sea level. That's where you and I are standing right now, and other living organisms, right? Because life is mainly found in the lowest 2 kilometers closest to the sea level. Now, the following layer of the atmosphere, which is the stratosphere, as you go up, right? So this one is the layer just above the troposphere, and it extends from that 10 kilometers to about 50 kilometers above the Earth's surface. And the air in the stratosphere is thin, right? Because we talked about density, right? The higher you go, the less dense it becomes. So the air in the stratosphere is thin compared to the air in the troposphere. And this is where we find some aeroplanes like commercial jets and other airplanes that are able to fly in the stratosphere. So now, looking at this picture here, right? As you can see, you see clouds, right? And the airplane is just above clouds. What did we say about clouds? We said that clouds are found in the troposphere, right? And the airplane is just above where? the clouds. So it means what? It is in the second layer now, which is the stratosphere, right? It is now flying in the second layer of the atmosphere, which is the stratosphere, and it is able to do so there because the air is very thin as compared to the one in the troposphere. So now, also in the stratosphere, we find a special layer called the ozone layer, right? So as you can see here, it says the stratosphere includes a band of ozone gas known as the ozone layer. So the ozone layer is in a form of oxygen, right? But when you remember oxygen, oxygen is O2, right? It has two atoms, right? So now ozone layer is different because it consists of it consists of three what? Oxygen atoms. Are we together? So the ozone layer is the form of oxygen in which the molecules have three atoms instead of the usual O2. So the ozone layer then, it occurs at about 10 to 40 kilometers above the Earth's surface in the lowest of the stratosphere. And also the ozone layer is there to absorb the sun's UV rays and also there to provide protection, right? The absorption of ultraviolet violet rays, it warms the stratosphere. So what happens is, during insolation, right, the heating of the sun, the ozone layer absorbs what? It absorbs all the sun's UV rays so that it gives us what? Protection so that we are not what? Experiencing extremely high temperatures. Then at night, during terrestrial radiation, right, when the air rises, also the ozone layer, which is in the stratosphere, it traps the air, right, so that we do not lose too much heat and we suffer from what? And we suffer from extremely cold temperatures. That's what the ozone layer is for, right? Providing protection in terms of sustaining heat and also what? Blocking too much heat from hitting what? The Earth's surface. Then the third layer of the atmosphere is the mesosphere, right? It is the third layer of the atmosphere from Earth, and also it extends from about 50 to about 80 kilometers above the Earth's surface. So the air there is extremely thin, right? It is extremely thin and also it is very cold, right? So the temperature decreases with altitude. The higher you go, the colder it gets in that layer, right? The temperature decreases with altitude. And also, the mesosphere is the top what coldest part of the atmosphere with temperatures ranging as low as minus 90 degrees Celsius. Then now, the last layer that we're going to discuss, the thermosphere, right? The thermosphere starts at about 80 kilometers above Earth, right? So it has the highest temperatures, right? Because it is closer to the sun as well, right? So the amount of gas in this layer gets less and less, diminishing slowly until space begins at about 350 kilometers above the Earth's surface. So it is closer to space. But now, here's an interesting part about the thermosphere. In the thermosphere, that's where we find our satellites orbiting from further away from the Earth, right? This is where we find satellites orbiting, right? So now, there are thousands of artificial satellites in orbit around Earth, and they are all found in the thermosphere. So now here is a picture to show a satellite, and this is what? Planet Earth, as you move with the atmosphere, going higher and reaching what? The thermosphere. But now, one would ask themselves a question. How is the satellite hanging there? So now, when you look at this layer of the atmosphere is closer to space, right? But at the same time, it's not further away from the Earth. And the Earth has what? The force of gravity. So now the satellites here are being pulled by the force of gravity. Yes, the gravity is not the same, right? It's not enough, but also it is enough to keep them floating there, right? So that they are not lost or they are not dropped down. Right? They are held together by the force of gravity, but they are still able to float because they are closer to space. Now, also, what are these satellites for? Right? They are used for our television connections, right? So that we can be able to get connection and internet, radios, and so on, right? Now, Let's test ourselves for the last time, right? Here is activity 2. It reads as follows. It says, copy and complete the table below. Indicate which layers in the atmosphere the characteristics in the left-hand column referred to by placing an X in the row under the heading of for that layer. So for layers, we have troposphere, stratosphere, mesosphere, and thermosphere. Then the descriptions, we have temperature decreases with altitude. Then you have temperature increases with altitude. Then contains the ozone layer. Clouds form in this layer and also has the highest temperatures. Only place an X to the correct layer. So now I'm going to give you 5 minutes to complete this activity. Then we'll meet again after 5 minutes. Welcome back again. Now, let's look at the solutions for our activity 2, right? So now, which sphere falls under the following descriptions, right? Temperature decreases with altitude. Which sphere is that? It is the troposphere, right? Not only the troposphere, but also the mesosphere, right? Temperature decreases with altitude. The higher you go, the colder it gets. Then temperature increases with altitude, and that sphere is the stratosphere, right? There's the stratosphere and also the thermosphere. Contains the ozone layer. Which one is that? That is the stratosphere. Then clouds form in this layer. Which layer is that? That is the troposphere. Has the highest temperatures, and that is what? It is the thermosphere. So let's just take a quick 2 minutes to copy down the corrections. Welcome back again. Now let's wrap up our lesson, right? By just summarizing what we have learned for today. So today we're talking about the atmosphere, and we said that the atmosphere is the mixture of gases held around the earth by gravity. We also said that this mixture of gases is known as air, which is the one that you and I breathe in and out. Also, we said that the atmosphere is one of the four parts of the Earth's system, and it is very essential for many processes of the Earth. Like, for example, we talked about what? It giving us carbon dioxide for plants to photosynthesize, us taking oxygen in for breathing and also for cellular respiration, nitrogen for helping with the manufacturing of proteins, and so on, right? Now, we said that also without the atmosphere, there will be no life on Earth. And we also said that the Earth's atmosphere is made up of four layers, namely the troposphere, the stratosphere, the mesosphere, and the thermosphere. We said that the troposphere is found from 0 to 10 kilometers above Earth's surface. Stratosphere found from 10 to 30 kilometers above the Earth's surface. Mesosphere 30 to 50 kilometers. Thermosphere 50 to 400 kilometers. Now, we also talked about the density of what? Of the atmosphere. And I've reminded you that density of a material describes the amount of mass in a given volume of that material. And we said that the most dense part of the material of the atmosphere is the troposphere that is found in the range of 0 to 10 kilometers. And the density of gas particles decreases with altitude, right? The higher you go, the less dense the atmosphere becomes, because the air becomes thinner and thinner as you go high, right? And I've shown you this picture to say that from 0 going upwards here, on the first numbers like 2, 3, that's where you find the most dense part of the atmosphere. And as you go up, that's where you find the less dense part of the atmosphere. Because of what? The air keeps on getting thinner and thinner, and the gas particles are further away from each other. So now, if you have any questions or comment, I will need you to take about 1 minute to ask any questions or comment on our WhatsApp number. Welcome back. So we didn't find any questions, right? So now, on the next lesson, we'll be talking about the greenhouse effect, right? So go home, study more on about the greenhouse effect so that when you watch this lesson again, it becomes easier to understand, right? And after you're done watching this lesson, don't forget to click on the complete and continue button, right? So that you can be able to view other lessons. So from me to you now, I'm heading to the stratosphere. Thank you, goodbye.